We can see that.
Awesome, awesome. Okay, so hi everyone. My name is Victor, um, and I'm currently a data scientist and machine learning engineer. So I'll be walking you through um, the challenge. I would also like to say that just as Teju has mentioned, the DSN bootcamp is a very impactful one, and I remember that it was one of the pivotal events that helped me shape my career as a data scientist, growing in Nigeria. And I think I was privileged to attend the 2019 bootcamp. That was my first data science Nigeria bootcamp, and subsequent years as well. I was um, I was present in that bootcamp. So I would say it's a very a great opportunity. So I try as much as possible to be part of the folks that will be selected to attend. And I think that if you actually give these hackathon your best, you should gather enough knowledge that would strengthen you to qualify or be one of the participants for the bootcamp. All right, so my name is Victor, aka Professor on the Zindi platform. And if you go to the Zindi page, for those that have not seen the hackathon at all, you can just navigate to zindi.com and try to create an account. And when you get there, you should then just click on this compete. Let me go back one step so that you see what the landing page looks like. So this is the Zindi landing page, and once you go to compete, you'd see like tons of hackathons that are there. The one we are working on at the moment is just go down to hackathons out of this competitions, hackathons, and practice. When you get to the hackathons tab, you'd see the Microsoft in collaboration with DSN free AI classes in every city. So this is the hackathon for your events, right? And I would encourage you to read through the description well, because that will give you a sense of the high level understanding of the problem or you're trying to solve, and hopefully gives you some sense of understanding of the challenge itself before you even dive into the data. Okay, and to access the data, you just find it in the data tab where you see the data sets that are available. Ensure you join. It's because I've joined the hackathon, that's why this button is showing submit. But when you join, you then find each and every of these individual files. So you can download them. I have already downloaded them, so they are already on my PC. Yeah, I've created a folder and I've put them in, just as you did for several of your practice classes. I've also created a starter notebook, which I have put in the discussions page. So if you have already registered for the hackathon and you've jumped on Zindi, you can find the notebook in the discussions page. So let me open that, and I've uploaded it on several platforms: GitHub, Google Colab, and Cargo. So whichever one you are much comfortable with, you can go there and then download it from there. So I just clicked on the Cargo link, and then you find the notebook, which you can just easily download via the download button. So you can just download the code locally on your PC and use it. Or if you want Google Colab as well, you can just leverage the Google Colab link, or GitHub as well. You can find it on GitHub too. Okay. Without out of the way, I would just get started. So this is the notebook, and I already have it downloaded and have it locally on my PC. I've tried to zoom out as best as I can. So let me go back one step. So hopefully you can see this really clearly. Okay, so let me go back to the first page. You'd see the nature of the hackathon. right? So it's an African telecommunications company, right, that provides customers with airtime and mobile data bundles. The objective of this challenge is essentially to build a machine learning model to predict the likelihood. So you'd see that there, likelihood of each espresso customer to churn, right? So what we're essentially predicting is likelihood, or as it were, probabilities of the customer churning or not. And if you go to the evaluation, you'd see the evaluation metrics that are being used. So for this hackathon, the log loss you know, is the metric that is being used. And then, Zindi already nicely puts a format for you that is expecting, so which is the user ID and the churn probability. So these are probabilities. 0.98 means, there's a 0.98% chance that the person will churn, which is close to 1. And, 0.12, this is a low probability. So this is closer to 0. Okay, and then for this hackathon, there are about 500 points. So you can be rest assured you get points. The more you participate in hackathons and rank high, the more you get points that will then allow you to rank on the Zindi entire leaderboard. And I'm currently ranked 1. That's because I've acquired lots of points and won several hackathons over the span of years. All right, so with that out of the way, I'll just jump into the notebook. I think you still have till August 30 to jump on it and get to the first place. And let me also show the leaderboard as well. I know some folks have jumped on, and I would hope that after the call, I would also see your names, somewhere on the leaderboard. Okay, so I've designed a notebook to help you get started with espresso churn prediction, which is the competition essentially. And I just put a nice screenshot of the competition here. If you need the password, you can reach out to Seju, that is hosting the event at the moment. You can just send a DM or and reach out, and you get the password to join the hackathon. Because this hackathon particularly has a password. Okay, so the data set description, if you go through the data page, you'd see you are given some files: variable definition, sample submission, test, and train. So I've just copied out what is inside the variable definitions and written it here. So you have a bunch of columns, and these are the definitions of those columns. And I feel that it's always good as a data scientist to clearly understand the kind of data and what each and every of those columns represent, and to be able to model your data properly. I would also say that you can keep your questions or ask them in the chat. I'll be sure to take them. Or if you have any question, you can also ask. All right. So first things first, we start by importing the necessary libraries. So I've just brought in a few: Pandas, NumPy, Seaborn, and Matplotlib. Right. By now you should be familiar with many of these libraries. Then to avoid warnings, that's why I just brought this in as well, so that all these warnings don't show on my system. And then I bring in the data, right? So I have 3 data CSV files. I have the train test and the sample submission. I just quickly load it in and name them respectively: train test and sample sub. This is what the train looks like. I'm just checking out the head, which is top 5 rows, right? So it looks like this. I have some sort of user ID. I have some region, tenure, month, frequency, recharge, revenue. I've gone through the data already, so I already know what each and every of most of the column names already mean. So you can as well check out the description again, which helps you understand what each and every of these columns mean. But essentially, what we are trying to do with this data is to predict if a customer will leave, a telecoms network or not, right? So you can check out the name of the telecoms company is called Expresso. So we are trying to figure out if a customer would leave this network and probably port to another network or not. And it's hopeful that when you can build models like this, the company can then use it to know if this customer will soon go, let's give more bonus to that customer now, or give more offers to that customer so that we can keep them, right? So that's one use case out of many which this solution can be used for. So the test set as well looks very similar, except that it does not have the target, which is churn. So it has everything except the target. And Zend is expecting that your sample submission will look like this. So bouncing off to EDA, right? I already did some EDA. The first one was to then plot a heat map to show all numerical values against themselves and see which of those data is strongly correlated to the churn, or which of them are even in some sort of way correlated to each other. And I can see that interestingly, I have like revenue and Apple segments strongly correlated. I mean, this is about 1.0 correlation already. So we'll take care of that as well in the course of the notebook. But in truth, if you actually look at it, the Apple segment is just the revenue multiplied by 3 in some sort of way. So this is income over 90 days, which is the average revenue, per user segment. So essentially, you would expect that, if you take the revenue for 3 months and divide it by 3, you get the Apple segment, which is most likely still the same as the revenue. And then there are other strongly correlated columns as well. I can see frequency and frequency recharge, which is very close, obviously. It's just the recharge that is even the difference in the name. From the variable definition as well, you'd find out that it's just the number of times a user recharged and the number of times the network made money from that user. I also tried to check out each of those numerical features and plot their distribution. So the numerical features being anyone that is numerical. You have frequency, recharge, revenue, Apple segments, and others, right? And just to see some sort of what the distribution looks like, whether it's left skewed or right skewed, or if it's evenly distributed as well. And I also did the same, trying to check out box plots as well. If you have ever done a box plot, you know that that helps you to spot outliers at a glance, right? So I'm then able to just use this to understand the nature of my data and see what kind of outliers are in my data sets. So that's why I have my box plots already done for each and every of those numerical features. And I also did the same as well for the violin plot, which of course is tells you some of the things the box plot already tells you, including extra additional information. Let me also say that some of the numerical data are somewhat clean or free from outliers at one of the labels, and that's why you'd see that for the box plot, I actually had to show the box plot for each label. So for 0 customers that didn't churn, and for 1 customers that actually churned. Okay, so also I decided to check out some of those features that are strongly correlated to churn, like which one is has high correlation with churn. And it turns out that in the positive correlation side, zone 1, even though this is really small, because this is 0.01, which is really, really small, it's zone 1. And then on the negative side of strength, we have regularity, which is minus 0.4. So it's negatively correlated, but it's still a very strong feature correlated to churn. And then I also decided to check the count plots of my targets to know, the distribution of users, how many people churned actually, and how many people did not churn in the data set. So I can see that, this is unevenly distributed. In fact, the ratio is highly imbalanced. So the EDA essentially, as you've done in some of the sessions you held during your classes, you'd have seen that it gives you, insights into what your data is all about, how the target is, how your data relates to each other, and how each and every of those targets actually relate to themselves. One other very popular EDA is to then check the descriptive statistics of the data. And it's simple. Pandas has a nice function to describe that, nicely does that for you. So it picks out all the numerical data, and it gives you, the count of those data, the mean, the standard deviation, the minimum, 25th percentile, 50th, 75, and the maximum in that data as well. So you can check it out and find if you find anything that is really off. And yeah, maybe you get more insights than I've done. All right. So after doing some sort of EDA, I then have some insights into, some of what the data is about. I've seen, some over-correlated, features in this data. I've also seen, turns out there are a bunch of outliers as well in some of those data, but I'll need to check them individually to be sure I need to remove them. And then I've also seen, features that I think, are strongly correlated to churn, and those that are probably, in some sort of way not correlated at all. And I've also seen from my EDA that I have, an imbalanced data, and probably I would have to deal with that as well. All right, so let's start processing the data now that we've done some sort of EDA. In this processing technique that I've written, you see how to handle missing data, and code categorical variables, and hopefully do other things like feature scaling as well. So I dropped the variable, that's the target variable from the train data. So I just named it churn. So of course the target, which is churn, or you can name it target, whichever one you like, is essentially just the train of the churn. And then you have the other part of the data which you train, as I've dropped churn from that as well, so that I can do a singular processing together. And when I say singular processing, I actually like doing this because many a times, especially when it comes to hackathons where you have your train and your test set, you most times have to start doing it individually, and practically it's more advisable you even do it that way. But then if you just want a quick, just a quick prototyping, you can then just combine your train and test, so that you do the processing at once rather than using the same code for your train and test, unless you write functions to nicely handle that for you. So I've combined the train and the test set together, and I've named it data. Remember now that my train no longer has the churn column, so it's exactly the same as my test in terms of the number of columns, because I've dropped churn, and then I've saved churn nicely in a variable called churn. Okay, so after combining the data, I have a longer data now. Not wide, longer, because the number of rows will increase, but I'm just checking the head, so you'd see the top 5. And now I can do, processing at once. So I'm checking for missing values here, essentially to know how many missing values are in my data. It turned out that I had data sets had 400,000 data points for the train, and some other data points for the test, which we'll see later on. But in total, the number of missing values for each and every of these columns are here. Of course, there's no missing data for ID. Region has about 196,000 missing data points, and so on and so on. Then, because this really is not really descriptive, so I had to nicely show the percentage of data that is missing, right? And it turns out that after writing this piece of code, the zone 2 has 96% 93.6% of the data set of zone 2 missing. So that's really, really high. Zone 1 as well has up to 92% of data missing. Others, like Tigo, struggles around 59 rather. So there's still more than half of the data missing in that column. On and on and on. I've already ranked them in descending order. So that is there. And then because, of course, zone 1 and zone 2 is almost totally useless because I have 93.6% of the data points there missing, I've decided to just drop them. So you are the data scientist. You can decide to drop more depending on what you benchmark as your missing values threshold. Good practice, 50%, 60%, of your data should be available, right? Some even go as far as 70, 80% should be available, right? But if you're having up to, 90% unavailable, that is just 10% or less than 10% is available, that's already far-fetched. So I've dropped them already to avoid any challenges because it's basically not so useful. And I've nicely written, some sort of description of why we actually would need to fill missing values ourselves. So you can read up the notes because I've decided to, fill in missing values in the next line of code. And then I wrote other strategies because you might want to try other strategies different from what I've already done. So to fill missing values, I did it in two simple ways because this is starter notebook, so I didn't want to do anything really, really complicated. So for the categorical columns, some people like to fill with the mode. You fill with the mode, but then I just decided to fill with word there called missing of that column. So for instance, for my categorical column, let's say top pack, for instance, instead of filling this none with the mode, I just fill it with missing top pack. So at the end of the day, I know that this is actually a missing top pack. And then for all the numerical columns, I just decided to fill with the median. It's generally good practice to fill with the median because the median is safe from outliers. But then you can also try other ones like the mean if you are sure you've dropped the outliers or you've taken care of the outliers. And then there are other methods as well, interpolation, forward fill, backward fill. And I've written why they might be better for other types of data where time is involved. So you can read that piece, and I'm happy to. I would be on the Zindi Hackathon throughout. So if you tag me or you ask questions on the discussions page, I'll be happy to answer. Okay. Also, I've decided to check out over-correlated columns. How did I know I was supposed to check revenue and Apple segment? I'm not a magician, obviously, so I just found that out from this. So when I saw 1111 here, I then decided to figure out, why revenue would be strongly correlated to Apple segments. Of course, this is understandable because each of these columns should be correlated to themselves. So montants should be strongly, 1.0 correlated to montants. But, finding a feature that is strongly correlated to another feature, revenue being correlated to Apple segments is really weird. So I decided to check it out, and then I found out that, as I anticipated and as the data already described, the Apple segment is just, the revenue somewhat divided by 3. So you'd find that consistency there, 18,000 divided by 3, on and on and on and on. Like you find it there. And of course, if you already read the data description, you'd see that, it's the revenue over, 90 days divided by 3, which is strongly related to 1 month's income. Okay, so I've decided to drop one of it. I just need one, so I've decided to drop one. I decided to pick revenue, and I've dropped it. And then for my categorical columns as well, I decided to check because now we have we've dropped the number of columns, and then we still have to undo the categorical columns. I think I would like to run this so that I can show what my data looks like. So let me run this. Yeah, so after dropping revenue, um, this is what it looks like. Okay, hopefully, sorry. Hopefully this runs real quick. Some of those plots take time to run. Okay, so after visualizing what my data looks like, hopefully this will pop up any minute now. I decided to check how many unique data points are in those categorical columns, right? So if you go back to my data, let me go back one step. You'd see in region we have Dakar, and we have a bunch of others. For tenure, we have K greater than 24 months. This is an object or a string. And then we also have others like top pack where we have some text there, data 100 equals to 40 MB 24 hours, right? So I decided to then check each and every of those categorical columns, how many of them are unique. So of course, user ID, this is expected since there are 500 data points there. Each user has a unique ID. So there will be 500,000 unique categories. For my top pack, it turns out there are 113 different top packages. You can drill down into it and see what it looks like. For region, excuse me, for region, you have 15 different regions there. So you can, check them out and see what each and every of those regions actually are. And for tenure, you have 8 different tenure packs there. And then there's something called MRG. And of course, you can always go back to the data description if you don't find, if you don't understand the meaning of any of those columns, right? So this indicates if a client is going to churn. So they have an indicator called MRG, but then it turns out that the MRG is no throughout. So it only has one category, which is no. So it makes no sense to actually use it because it has only one feature present. So I've decided to just drop it. Why? Because it's not useful, right? It's just one category that is there all through, which is no. So I've decided to drop that. And then for all my categorical features, since this is a starter notebook, I decided to go lazy about it. So I just dummied everything by writing a single line of code, pd.get dummies. And then you convert the entire region, top pack, and tenure to dummy variables. And now that that is done, I can drop the user ID as well, because of course you don't use the user ID during training. And then I split the train and test set. So this is the train. Of course, remember I combined it at the beginning so that I can pre-process everything at once. So that when I drop user ID, I don't have to write drop user ID for train, drop user test, right? And then I've splitted them back into train and test respectively. I decided to jump straight to Card Boost. I'm sure you'd have started off with several smaller models, maybe logistic regression, and maybe other linear models as well. And then hopefully you've also done decision trees, during the course of your learning stage, right? So Card Boost is also a top classification. The Card Boost classifier is a top classification model. So you can try that out as well. There are other ones like XGBoost, Light GBM. They are popular in the competitive data science space. So I'll just import them. Import Card Boost classifier. Of course, train test split. I've already splitted it into my train and my test, but I then need to split it again into X train, Y test, Y train, Y test. And of course, metrics as well. I've imported a bunch of metrics which are popular in classification, right? Accuracy score, classification reports, log loss, and the confusion matrix. Of course, remember that the competition actually is testing the log loss, right? So if you go down to evaluation rather, you see it nicely there. The evaluation metric for this challenge is log loss. It's there. So that means I will need to also check out the log loss to ensure I'm doing well. And then I split the data into X train, X val, Y train, y val. And then I've decided to pick a test size of 0.2 and just set a random seed to 42. Training a model is as simple as ABC, right? It's just simply saying classifier after instantiating an instance of your classifier model, right? Classifier.fit, and you pass in X train, Y train. And then you can also pass in some other hyperparameters if you like. I decided to do that. Loss function, log loss, since that's what the competition is evaluating on. So I've decided to make my objective log loss. And then the learning rate is 0.01. I've told it to use best model. There's a nice parameter in CADBoost called use best model. And then the evaluation metric as well is also log loss. And of course, if you be using anything as such as this, it means if you use evaluation metric here, you then need to pass in an evaluation set, which I've nicely done as my X val, Y val, where I did after I split it. And then training the algorithm just took a few minutes. Let me try to see how I can run this so that we can do this live. Let me go back to where I stopped running it, which is this data, right? So this is the data you have now. I have 15 columns, and by the time you do all these extras, you should have many, many, many more columns. Okay. So because of the dummy variable would actually make all those categorical features as columns. So you'd have lots of more columns now. I mean, expanded to almost 143. So you can find if there are better ways you like to handle them, right? Because this is tenure G, 12 to 15 month, tenure H, so I feel there are better ways you can go about this rather than just making everything a column. Okay, so where are we? So I would like to run this live. So let me import my CADBoost classifier and then split the data X train, Y train, X val, Y val. And then I'm going to train the model. So training the model should just take a few minutes, just about, I think, 4 minutes or so, or lesser, probably. And then after you train the model, you then, of course, want to evaluate, the model before you submit to Zindi. And of course, the popular metric is accuracy, but in the data set we are working with at the moment, accuracy is not the objective. But of course, you can still nicely print out the accuracy so that you can see it. So the model is still training, would allow that to train nicely. And then I also brought out the classification report. Accuracy is already about 87%, which is fair enough, I guess. Classification report as well. I've printed out the classification report nicely. You have the precision, recall, and F1 score for each class. So this is the class 1, which is the class we're interested in. And we have 0.68 and 0.65 for recall. F1 score is 0.66, not so bad. Accuracy has been approximated, which is 0.877 to 0.88. And then other metrics like the macro average and the weighted average. Accuracy. And then we have as well the log loss, which of course is the metric that we have been evaluated on. Locally, I was able to get a 0.25x, right? 2555 on and on. 25x log loss. Let me see if this has finished training. Okay, it's 900 and 1000. Yeah, so the default for CADBoost, the default number of iterations is 1000. So that's why I had to train for 1000 iterations. So let me check if my accuracy changes. No, it doesn't. And then my log loss as well remains the same, 25.5. I'm sorry, 0.255. And then I have nicely plotted, the confusion matrix for those, that would like to see the true positive, true negative, false positive, and false negative. And then this is something I'm accustomed to doing personally. I think you could also leverage it to do your feature selection, the feature importance plot. Like what features are more important or most important in in my data set. So you can nicely pull that out from some models. Some models allow you to nicely pull that out. Card boost, and no random forest allows you to do that, and a bunch of others. So I'll just plot this very fast. So it turns out that my missing region, right? Most of the missing region happens to be the top. Interestingly, and regularity as well. Data volume, obviously, this is obviously we know that the more you subscribe and recharge, most likely the more you're enjoying the network, and a bunch of other features as well, which you can check through. All right, so now that everything is said and done, we can then just create a submission, right? A baseline submission. So creating a submission is simple. You've trained the classifier already, right? And you've named it classifier, right? That calculus classifier. So you just do classifier.predict. But remember that now you're predicting the probabilities, because if you just predict, right, you just get zeros or ones, and that's not what we want, right? Zindi says that, they want to evaluate via log loss, right? And that means that you have to give them the likelihood, right, that the customer will churn. So you are submitting probabilities, not actual zeros or ones if a customer will churn or not. So you are going to speak, as I like to say, predict proba, right? So this nicely will tell you the probability, and I'll pick the one side, which is probability that a customer will churn. And then I've just created a sample of the sample submission and replace the entire churn column with my predictions pulled out from my prediction of the test set. Right? And now when that is done, I can save it as a CSV file, and that's why I have this. I've saved it as a CSV file, and then just to see the first few rows, this is what I have. I think I'm getting a feedback. So if you're not speaking, I think that's Prima. Prima, if you're not speaking, you can just nicely mute. Thank you so much. And then now that I've submitted to Zindi, interestingly, on my first submission, I got a score of 0.25, which nicely at the time placed me at number 3 on the leaderboard. But there's a good man now that has beaten me from number 3. Interestingly, he's not a Nigerian, so he has submitted and he has bounced me out of number 3. But of course, I feel the baseline notebook should get you up to speed and at least get you to a score of 0.251x. So this is the score I achieved with this notebook, and then I already put in it, lots of instructions on how I think you can still get better. One is that of course you have to clean the data and ensure that you do proper justice to each of those data points. I was really lazy about it, so I just decided to make everything dummy. Right, so check out the tenure, region, top pack. You can handle it better essentially. Do some feature engineering, try to see if you can create new features, or then you can select features as well by eliminating features that you think don't make any sense. Excuse me. You also have missing value imputation, right? There are some models that allow you to pass missing values. So you can leave the missing values and see, or you can also use other advanced strategies to fill in your missing values. I was also really lazy about it. I just filled the numerical values with median, and then the categorical values I just wrote missing there. Hyperparameter tuning as well. You could check that out. Check out the Optuna, and maybe you can do a grid search or random search. You could build a bunch of models and then assemble them, right? Maybe build random forest, build logistic regression, build cat boost, and merge the predictions together by taking the mean, or just blend with some sort of with a measure of central tendency. It can be mean or median, or any of those other measures. Also, you could do a cross validation, because when I was doing this, there's no cross validation at all. I only fitted once, just to make it simple, right? And try other algorithms, right? I mentioned XGBoost, I mentioned LightGBM, and I know a lot of folks are using simple algorithms at the moment. So you could start from simple and go all the way to boosting algorithms like what I've used. And then, of course, you have to undo imbalanced data. I ran away from this, so you could probably check that out as well. There's a parameter called class weights in many of those models where you can adjust the class weight while training. Many of you would have heard of smooths, right? Where you need to oversample or undersample a particular part of the data. So that's something you can leverage on as well. So happy hacking. I hope with this you'll be able to get started. To submit, after running this, I think I was running this, so let me just finish it. After running this will nicely give you a CSV file in your working environment called baseline submission card boost espresso. So when that file, you need to just upload that file nicely to the submission section. So if you come down to the submit section, just click on submit and then click here, and it would open some folders for you. Try to navigate to that folder. You won't be able to see that because I'm not sharing my entire screen. I'm just sharing a tab. So you select the oh, sorry, I selected the wrong thing. So you just select nicely your submission.csv file. So let me look for that. Okay, so I found it, and then when you click submit, of course I don't want to submit again because I've already submitted it before. So when you submit again, you have this nice score here, 0.2516. It might change, well, because I didn't set random states everywhere, so you might either get a better or slightly, I mean, it will be very close anyways to this score that you have. Okay, so with that, I hope you'll be able to get started and see how you can improve, see how you can learn, experiment, try, and let's see your name pop up somewhere on the leaderboard. All right, so that brings me to the end of it. I'm happy to take questions, share my thoughts, and try as much as possible to, of course, use the discussion forums a lot. When you have errors, right, instead of DMing someone, you can just nicely write it here in the discussions and maybe also send it to a group if you're in a DSM, one of those DSM group. I know the Telegram group is quite active. You can also use the discussion forums here. People that are on the leaderboard, they'll be happy to answer you. So, yeah, so that's it from my end. I'll just stop sharing my screen now and hopefully take questions. Back to you, Teju.
Okay, thank you very, very much for this topic. You can even write in the link just following the chat. So just follow the just look I'm waiting for you to do that. Everyone on this call, let's celebrate him for a job well done. Thank you very much, Victor. So I want to know if you have any questions, you can just unmute or drop it in the chat for Victor to pick up. So if you have any question, please.
Sorry, I don't know if it's just me. I'm struggling to hear you at your end, at my end rather. So
Okay. Hello.
yeah,
Is it better? Is it better now?
yes, it's much better now. Thank you.
Okay, good. Thank you very much for calling my attention to that. So I say thank you everyone for joining and for staying to the end. Okay, so if you have any question for Victor, you can ask now. You can drop it in the chat and then you can also unmute. Now, when you register for this, I've dropped some link on the chat. When you register for this hackathon, that is when you have access to the secret code to join. Now, this hackathon is for majorly for those who participated in the free AI in every city program, but it is open to everybody, every DSNer to participate. But what you just need to do is to register on the link I've dropped on the group, and after registering for the hackathon, then you automatically get an email with the secret code and other necessary details, that you need to that you need to fill. So please, it's very important for you to be part of this. As I've earlier stated, that it's actually one of the important checkpoint for the DSN All Expense Paid Bootcamp that will be coming up very soon. Okay, so please, I want you to participate in this to, and then I'm very sure you're going to enjoy the experience. Okay, so do you have any question already in the chat? Okay, yeah. Any question? Nobody? It means that we all understood the section.
Can you hear me?
Yes, we can hear you.
Okay, I came late actually, so I don't know if we can get access to the Jupyter notebook that was just used.
Yes. So the digital notebook is already on the platform. So he has uploaded it on the Zindi platform. So just register for this, for the hackathon, and then you have access to it. I get it. Okay, that's just it. So also we'll be dropping it on the chat. We'll be dropping it here. We'll be dropping the starter notebook on our Telegram, on our Telegram group, just to make it very easy for you to access. Okay, good. So any other question for Victor? Okay, so in the absence of any question, thank you very much, Victor, for taking your time to take us through this. So this session will be.
Okay, you're welcome, Teju. I was just going to say once again that I would encourage folks to use the discussions as well. Like if they have challenges, running the notebook or they need help to get started. I can see a lot of bosses are also on the hack as well. So there are a lot of folks that would nicely love to help you resolve your errors. Yeah. So thanks once again for having me, Teju, and thanks once again, everyone.
Okay, thank you very much, Victor. So please let us take note of that. There are a lot of data scientists on the Zindi platform that are ready to respond to your questions. So let's make use of the discussion, the Zindi discussion group. Okay, so in the absence of any other question, so thank you everyone for joining this meeting. There's still going to be an AMA session tomorrow. Please watch out for it. It's for other tracks. And then it's just for you to ask any question regarding the project that you're currently working on. So thank you. So this recording will be uploaded on our YouTube so that you can have access to it. Okay, so take care of yourself and enjoy the rest of your day. Bye.